Hello, welcome to the fifth day of this chapter. Today we're going to be completing the square with ellipses, circles, and hyperbola. Now before we do that, first let's review what we learned the previous day, and let's write the equation in standard form of this conic section. Hopefully people can tell that this is an ellipse. So an ellipse is in the form of something squared plus something squared is equal to 1. Now the denominators on each of these, well, first of all, let's say that this is x and this is y. The denominators are how far of a stretch it is. In the x direction it only goes 1, and in the y direction it goes 1, 2, 3, 4. So we have a 1 there and a 4 there. Now I want to move my graph to the left 3, so that's x plus 3. I also want to move it up 2, so that's minus 2. So from that, we have our equation of our ellipse. Now what kind of graph will this be? Now when we're deciding what kind of graph this will be, first off, both of these are squared and those are the highest exponents, so we can get rid of the parabola. Parabolas only have one of two variables squared. Now we can also not think about the rest of the equation because we only look at the things that are squared. There is a 1 here and a 1 here. They're the same number, but they have unequal signs. Both circles and ellipses need those signs to be exactly the same. So hyperbola is the only one where we have different signs. Alright, so let's write the standard equation for each graph. Circle is x minus h squared plus y minus k squared is equal to r squared. Ellipse, we have x minus h over a squared plus y minus k over b squared, and that's equal to 1. And my hyperbola, one of these two is negative. So we say x minus h over a squared minus y minus k over b squared equals 1, or, I'm sure this won't let me do it, no. Or the first one is negative and the second one will be positive. Alright, so how can we easily find information about these equations? Well, the first thing I can tell about these equations is that this is an ellipse and this is a hyperbola, because this one has unequal coefficients but both the same size. These have different signs, so that's what I can tell. However, from this equation I can't tell anything else except for the fact that it is an ellipse. And same thing with this. Can't tell anything else except for the fact that it's a hyperbola. So what we need to do is write this in standard form in order to graph it much easier. So our goal for these next problems is to determine whether the equation represents a circle, ellipse, hyperbola, or parabola, then complete the square to put the equation in standard form, and then find the key information and sketch the graph. Alright, here we go. These have unequal coefficients, but the same side, so we know, first off, it's an ellipse. Now let's complete the square. Now our first step is to put our x's together. So I have 9x squared minus 18x. Put my y's together, plus 4y squared plus 16y. And what I like to do with these is I like to put the 11 on the other side. So if I add 11 to both sides, this would be equals 11. Now, some teachers teach this and they do everything on one side. I like to do everything, things on both sides. Alright, now if we're going to complete the square, first thing we need to do is pull out a 9 here, leaving x squared minus 2x. I'm going to leave a blank there because we're going to fill something in. Here I need to take out a 4, so that's y squared plus 4y. Now we have to think about what would make these perfect squares. Over here I'd have to add a 1, and over here I'd have to add a 4. Now really I'm not adding a 1 to the left-hand side, I'm adding a 9. So I could achieve the same result, or I could make this equal if I add a 9 to the right-hand side of the equation. Now, similarly, here I'm not adding a 4, I'm really adding a 16. So now my right-hand side of the equation, I add the 16, and I have, what's this, 20, 36. And over here I have 9, x minus 1 squared, plus 4, y plus 2 squared. Alright, now this is an ellipse, so the right-hand side has to equal 1. So I'll divide by 36 on both sides, leaving a 1 on the right-hand side. And over here, if I broke this up, it would be x minus 1 squared over 36 plus 4, y plus 2 squared over 36. Now 9/36 is the same thing as 1/4. So we can say this is like 1 over 4. 4/36 is the same thing as 1/9. So put that over 9. Now the last step here to put it in standard form. Our standard form has parentheses over the whole thing. So if I wanted to do x minus 1 like this, what number squared will give us 4? The answer is 2. And now if we do the same thing over here, y plus 2 over 3, because 3 squared will give us 9, is equal to 1. Now this is written in standard form. So if I want to draw the graph, I do something like this. I go 1 to the right and 2 down, and make my first dot. Now, this moves 2 to the left, so 1, 2. 2 to the right, 1, 2. Up 3 and down 3, 1, 2, 3, 1, 2, 3. And now we have our 4 vertices, and so now I can draw my ellipse. Alright, there's my ellipse. Alright, let's try this one. Now first off, this is positive and this is negative, so we know that this is a hyperbola. So we put our x's and y's together, and luckily they are together here. So I have 1/9 x squared is like x squared over 9. Here I can take out a negative 4, leaving y squared minus 10y. Now what I have to add to this will be 25 to make it a perfect square. So really what I'm adding to this side is negative 4 times 25, which is a negative 100. So I have x squared over 9 minus 4, y minus 5 squared is equal to 4. Now a hyperbola always has a 1 on the right hand side, so we divide each section by 4. Now this leaves x squared over 9 over 4 is x squared over 36. So this is a subtraction sign. 4 divided by 4 will cancel out, and this would be just y minus 5 squared is equal to 1. Now if I want to put this denominator in the square, so this would be x over 6 squared minus y minus 5 squared is equal to 1. Now I have my hyperbola in standard form, so now I can draw this out. I don't move it to the left or right, but I do move it up 5. 1, 2, 3, 4, 5. Now, oops. This is actually kind of like an over 1, right? So, for my hyperbola, the first thing I can do is now make my asymptotes. So I go up 1 over 6. 1, 2, 3, 4, 5, 6. So that's that point. Down 1 over 6. And I can do it on the side. 1, 2, 3, 4, 5, 6. And I can hopefully connect my points. I'll do it with this weird line. And this one. So that's my hyperbola. Or those are the asymptotes for my hyperbola. Since the x is positive, it's going to open to the left and to the right. So I go 6 to the right of my center, 6 to the left of my center, and now I draw my hyperbola. And there you go. Alright, let's try another one. Now, if you're getting the hang of this, pause the video, do the best you can on your own, and then start up and see if you get the same thing. Well, the first thing I do is put the x's together. And put this on the other side, so that would be equal 26. So out of these two, I take a 2 out. Over here, I can also take a 2 out. Now, one thing I didn't do, the first step, it says determine what it is. Since those two are both the same number, this is going to be a circle. Alright, so here, to make this a perfect square, we need to add a 4. Over here, to make this a perfect square, it has to be a 25. So really what I'm adding is 4 times 2, which is 8, and 25 times 2, which is 50. So this becomes 2x plus 2 squared plus 2y squared minus 10y plus 25. Oops. I don't know why I didn't just simplify that there. Because we already have that's a perfect square, so it's just going to be y minus 5 squared. And now my right-hand side is going to be, what's this? 34. So this is going to be 84. Alright, so now what we can do, because we can divide both sides by 2, and now we have an equation in standard form that is x plus 2 squared plus y minus 5 squared is equal to 41. Alright, now r squared is equal to 41, so my r is going to be the square root of 41. Well, first let's find the center. The center is at negative 2, 5. So I move to the left 2, up 5. And that's my center. Maybe I should pull this graph down a little bit. And now, square root of 41. Square root of 41, we know square root of 36 is 6. Square root of 49 is 7. So it's somewhere in between there. So we go between 6 and 7 in every direction from the center. So I'll go up 1, 2, 3, 4, 5, 6. Between 6 and 7 is right there. I'll go to the right. 1, 2, 3, 4, 5, 6, 7. So it's right in there. 1, 2, 3, 4, 5, 6, 7. So right in there. And then 1, 2, 3, 4, 5, 6, 7. Right in there. And now from those 4 vertices, I can draw my circle. And there you go. All right. Let's try this one. Again, if you are having trouble with these, It's always good to pause the video, do it on your own, and then see how well yours matches mine. First thing we do is put our x's together, put our y's, oh, no, there's only one y, and then put the number on the other side, negative 288. We can see right away that the signs are different, so it's going to be a hyperbola. And we can take a 16 out of each of those. So 16x squared. 96 minus 16. Is that 6? Looks like 96. That's 6. So minus 6x. Now what I have to add here to make it a perfect square is 9. So 9 times 16, I should probably know, but I don't. So that's what we're going to add to this side. 9 times 16 is 144. So that makes this negative 144. So we have 16 times x minus 3 squared minus 9y squared is equal to negative 144. Now the right-hand side has to always equal 1, so we divide by negative 144. Divide by negative 144 on both sides. And so over here we have 1, which is what we want. Now we have 16 divided by 144, which is 9. So let's move this down a little bit. So this would be x minus 3 squared over 9. That's 9 over 144. Ooh, and this is a negative, so that would make that a negative. But a negative over negative will be a positive. So this would be y squared over 16, because 9 144th would be 1/16. Now if I want to extend this to the denominator, so we can write this in standard form, we just have to take the square root of both of these. So that's going to be y over 4 squared is equal to 1. Alright, now that's in standard form. Now we need to draw our graph. It goes 3 to the left. So 3 to the left, not up or down. And I'll make my dot, my center point. Now my slopes are going to be plus or minus 4/3. So I'm going to go up 4, 1, 2, 3, 4. And I'm going to go to the right 3. That gets me back to the axis. I'm also going to go down 4, 1, 2, 3, 4, to the right 3. I'm also going to go up 4 to the left 3, down 4 to the left 3. Now I'm going to get asymptotes, this dotted line. Alright, so now I have my asymptotes. Now my y is my positive number here. So that means I'm going to go up 4 in each direction and make a dot. And then bring this out to my asymptotes. Just like so. Alright, so there's my hyperbola. We have one more example to go through. Again, I want you to try this one on your own, see how you do. First thing I do is put the x's together. X squared minus 6x plus 4y squared minus 24y. Now put this on the other side, and that equals negative 39. I can take a 3 out of both sides here. That would be a 2x. I can take a 4 out of both here. Now I can add 1 there, and I'd have to add 9 here to make those perfect squares. But really I'm not adding 1, I'm adding 3. So I have to add 3 here, Here I'm not really adding 9, I'm really adding 36. Now, this is going to be an ellipse, because both of those are unequal. Alright, now if you notice something on this right-hand side, it's going to be negative 9 plus 39, which equals 0. Now, 0, there's no way we can add or subtract, or we can't multiply or divide anything to get from 0 to 1, which we want a 1 on this side. And since we can't do that, there's no way we can put this in standard form. This is actually not a graph at all. This doesn't represent anything, because it's like a circle with a radius of 0, or an ellipse with a radius of 0. It's so small, so in this one, if that ever happens where the right-hand side equals 0, there's no solution, no graph for this. Alright, now here's your worksheet. Good luck.